Okay, this is exercise 5G, trig identities. We already know the reciprocal identities. We've looked at those in detail before, that cosec theta is 1 on sine theta, again looking at the third letter. Sec theta's third letter is C, so it's the reciprocal of cos. Cot's third letter is T, so it's 1 over tan theta. Again here, that's provided that sine theta doesn't equal 0, cos theta doesn't equal 0, or tan theta doesn't equal 0, because you can't divide through by 0, and also cot theta doesn't equal 0 because that's undefined as well. All right? Now, these are new, the two ratio identities. That tan theta is sine theta on cos theta, and you know how cot is the reciprocal of tan? I'm going to derive this for you, okay? So tan theta is sine theta on cos theta. Some of you may have seen it last year in 5.3. But remember that cot is the reciprocal of tan, so it's the cot theta is a reciprocal of tan, so if tan is sine on cos, then cot is cos theta on sine theta, okay? So we need to know these. I'm going to do a little proof for this, okay? So let's say, I'm just going to use a Pythagorean triangle, just a triad to make it nice and easy. So let's say I've got theta there, so I'm just going to proving that. Let's say I've got this right angle triangle with a Pythagorean triad 3, 4, 5. What does sine theta equal? What's sine theta in this triangle? 3 over 5. Good. In this triangle, what does cos theta equal? 4 over 5. And what does tan theta equal? 3 on 4. Now, what I'm going to do, I know that tan theta is 3 on 4. That means that sine theta over cos theta should also equal 3 over 4. Because I'm trying to show that tan theta is sine theta divided by cos theta. So what I'm going to do here, sine theta divided by cos theta is 3/5. Now, instead of going divided by 4/5, I'm going to put it next to it. Is that okay? So sine theta divided by cos theta is 3/5 divided by 4/5. Which is, how do you divide by a fraction? You multiply by the reciprocal, and what do you get? You get 3/4. So therefore, we can see that tan theta equals 3/4. Sine theta over cos theta is also equal to 3/4. Therefore, tan theta equals sine theta over cos theta. Now, I could do it for any general triangle by just calling it ABC, for example. And I would get the same thing happening. So girls, we have to remember this one, that tan theta is sine theta on cos theta. And if you know what tan theta is, then you know what cot theta is. It's the reciprocal, cos theta on sine theta. Okay, so these are important. They're new. You need to know these. Just write down that proof. 3 complementary angle identities. Okay. Now, those 3 complementary angle identities, cos of 90 minus theta equals sine theta. And I could also write that sine of 90 minus theta equals cos theta. So it works the other way around, all right? So I could also write that sine of 90 minus theta equals cos theta. In other words, cos and sine are complementary. But you already know that one. You've seen that one. Now, how are you going to remember that cos and sine are complementary? The way you can remember it is, now I'm going to do some more here, but you know cos is really cosine. Cos is short for cosine, and sine is short for sine. Now, what is the difference between those two words? Cos is co for complementary. Okay, so cos is the shorthand way that we write. It's actually the cosine ratio, and sine is the sine ratio. The difference between those two are the letters co. Co is short for complementary, okay? Now, but then cot, you can see it with cosec and sec. See the difference is the co. That one you can see quite easily. But cot, so cot actually means cotangent. So when you see the tan ratio, it really is the tangent ratio. So tan is short for tangent ratio. Cot is cotangent. That's what it means. Difference between those two words are co, which is short for complementary. So cot and tan are complementary ratios. So the cot of 90 minus theta equals tan theta, or I could say that the tan of 90 minus theta is cot theta. Now we'll do examples in a minute, all right? We're just seeing which ones go together. Now, cosec and sec you can see quite easily. Sec, cosec. So they're the ones that go together. The ones with the co. They're the complementary ones. Now, the last one, cosec 90 minus theta equals sec theta, or sec 90 minus theta equals cosec theta. Again, cosec actually means cosecant, but for that one, it doesn't matter because you can just see the words anyway. And sec means secant. And the difference between those two words are co, which is short for complementary. So there are three, you might say there's 6 complementary ratios. It sort of is 6, but the first two are really the same. That the cos sine is one group, cot tan is another group, and cosec sec is your last group. Please don't get it mixed up with the reciprocal ratios, because the reciprocal of cosec is sine. It's third letter, and the reciprocal of sec is cos. So it's not the same groupings as the reciprocal ratios, except for the cot one has the same groupings, but the others don't. So you're looking for the word co that joins the two. And you can see it in cosec and sec. Cot and tan always go together, and cos and sine are reciprocal ratio, not reciprocal, are complementary ratios. So complementary ratios, see the word co, cot and tan, cotangent, tangent, complementary ratios, sorry. And cos and sine, cosine and sine are complementary ratios. Now, I've got a little proof down here. So that's how you remember it. That's the way you remember it, okay? By what their full words are, their full, yeah. Angle ABC, if this is theta, this other angle up here is 90 minus theta. So the cos of 90 minus theta is cos with respect to this angle, which is what? Go. What is it? Cos of this angle. What have you got? Come on. What's the cos of 90 minus theta using the triangle? Cos. Adjacent. A on C. Adjacent. From cos of 90 minus theta. So girls, if this is a right angle, that's theta. This will be 90 minus whatever that is. So cos from this angle is adjacent over hypotenuse. What's the sine of theta? From this angle now, that's your point of reference. A on C. Can you see they're the same? Okay, so therefore cos theta, cos of 90 minus theta equals sine theta. Now, cot. Let's do tan theta first. What's tan theta? Anyone? Tan? Good. Now, cot of 90 minus theta. Cot is the reciprocal of tan. Tan would be B on A, so it's A on B. Okay, so you can see that cot of 90 minus theta equals tan theta. Okay, and cosec is the, so just underlining those third letters anytime you see the reciprocal ratios. Just work out what sine would be. Sine of 90 minus theta would be B on C, so cosec is C on B. It's the reciprocal. You okay with that? Sec is the reciprocal of cos. Let's see what cos of theta is. What's cos of theta? So girls, to do sec, I'm doing cos first, B on C. So sec is the reciprocal of that, C on B. Okay? So therefore cosec 90 minus theta equals sec theta, sorry. Cos of 30 is the same as sine of what? Girls, they're complementary. So the two angles have to add up to 90. Sine of 90 minus 30, which is sine 60. Do you want me to write it as 90 minus 30, which is sine 60? But after a while, you'll see cos and sine together. The 30 plus what gives me 90. All right? Cot of, let's say, 20. What's its partner? Tan of, 90 minus 20, which is tan 70. Or 20 plus what gives me 90? Complement. And sec of, let's say, 50, what's its partner? Sec and cosec. No, you're thinking reciprocal. Sec and cosec. So it's cosec 40. That's how the complementary ones work. Because sec goes with cosec, cot goes with tan, cos, which is cosine, goes with sine. Now you should already know the cos and sine from our exact values triangle. Whatever sine 30 is, that's the same as cos 60. Okay? Girls, we should know, for example, that cos 30 is sine 60. Cos 60 is the same as sine 30. Cos 45 is the same as sine 45. They're complementary. Okay? Green identities that we're going to look at. Now, what I've drawn here is a circle. Center 0. Radius R. What is the formula of a circle with center 0, radius R? We did it in the functions topic. General equation of a circle. X squared plus y squared equals R squared. Very good. X squared plus y squared equals R squared. That's the equation of a circle. Equation of a circle, right? With center 0, 0, radius R, which is what I've drawn there. So here on my diagram, if I've got this point P on the circle, this is my radius. I'll draw a right angle triangle. And if this is the point P, x, y, then this is x units across, y units up, and I've got a right angle triangle. So basically what I've got there, I'm going to draw it again a bit bigger here. That triangle is down here. I've got x, y, and r. So I've just expanded that right angle triangle and drawn it here. That's my center 0. Here is a point P on the circle with coordinates x, y. We've sort of done this before. Now, can you just tell me what sine theta is and cos theta in that circle? Yeah, so I've just expanded this triangle down here. Sine theta is y on r and cos theta is, very good. Okay, so I've expanded this triangle down here. Sine theta is y on r, cos theta is x on r. I know that the equation of a circle is x squared plus y squared is r squared. I'm going to divide through by r squared. So divide each left-hand side and right-hand side by r squared will give me x squared on r squared plus y squared on r squared equals r squared on r squared. What's r squared on r squared? 1. Good. Now, girls, if x on r is cos theta, what's x squared on r squared? Cos theta squared. Now, it's cos theta squared, but you actually don't write it like that. And if y on r is sine theta, then y squared on r squared is sine theta squared. But that's not how you write it. That's not convention. The way you want to say cos theta times cos theta, you don't go put it in brackets like that and square it. You actually write it like this. Cos squared theta plus sine squared theta equals 1. But that does mean cos theta squared plus sine theta squared. Okay, that's how you write it, cos squared theta. That's our first result. Cos squared, so we have to remember this Pythagorean. Why is it called a Pythagorean identity? Because it comes from Pythagoras' theorem as well. Well, a right angle triangle. Sorry, it's one of his identities. So cos, so instead of, are we okay with this, girls? Because if x on r is cos theta, then x squared on r squared is cos theta times cos theta or cos theta squared. But you write cos theta squared like this. Please do not put the squared after the theta. It's cos squared theta plus sine squared theta is 1. Recognize that cos theta times cos theta, which is cos theta squared, is written this way, cos squared theta. Sine theta times sine theta is sine theta all squared. It's written like this, sine squared theta. And we say it as sine squared theta. Okay? Now, that's our first Pythagorean identity. So to get the other two, all we do is divide. Now, if I start with that again, and if I divide everything by cos squared theta, So I'm going to divide everything by cos squared theta. Now, wait a sec. I better put some instructions. So I take my first identity. So from the first identity, we can derive the other two identities. So first thing is, if I divide through by cos squared theta, I get, so I take that. So this is the one you learn. Cos squared theta plus sine squared theta is 1. Now divide left-hand side and right-hand side by cos squared theta, which means you're dividing each thing by cos squared theta. Now, what's cos squared theta on cos squared theta? 1 plus. What's sine on cos? We just did it. Tan, but it's sine squared on cos squared is tan squared theta. Good. And what's 1 on cos? Is it cosec or sec? Third letter. Sec. But there's 1 divided by cos squared will be sec squared theta. That's your second identity. Now it comes from the first one. So if you learn the first one, cos squared plus sine squared equals 1, sine squared theta equals 1, guess what? That's on your formula sheet. Okay? Then you divide them all by cos, or you can remember the little rule, it's. I remember this as it's. 1 plus tan squared equals sec squared, because they've all got squared in them. It's 1 plus tan squared, oops, equals sec squared. Now the last one, so we've got cos squared theta plus sine squared theta equals 1. It's 1 plus tan squared theta equals sec squared theta, because it's the only one that, because sine's already gone. Do you know what I mean? And then we've got, starting again with cos squared theta plus sine squared theta is 1. See, I divided through by cos theta that time. What do you think I'll divide through by now? Yeah, so divide through by sine squared theta. And what are we going to get? Cos squared theta over sine squared theta plus sine squared theta over sine squared theta equals 1 over sine squared theta. So you start with the first ratio, and you can divide everything by cos squared theta to get your other ratio, or you can divide everything by sine squared theta. What's cos on sine? It's the opposite of sine and cos, which is, sorry, not tan. It's the reciprocal of tan. Cot squared theta plus sine squared theta on sine squared theta is 1. What's 1 on sine? Cosec. Now, 1 is, and we like to write it the other way, 1 plus cot squared theta equals cosec squared theta. That's the last one, same as that one. Okay? So I'm going to write the 3 of them out. Look, the way I remember it is 1 plus little c equals big C, but you can't use the cos and sine again. Do you know what I mean? So your 3 ratios are as follows. Let's go. Cos squared theta plus sine squared theta is 1. The next one, it's 1 plus tan squared theta is sec squared theta. You don't repeat, none of them get repeated. Do you understand what I'm saying? All the 6 ratios get covered. And what's the last one? 1 plus little c, that the only little ones left is cot squared equals big C, the longer one. And there's your 3 reciprocal ratios. If you want, 1 plus little c equals big C. Big being long.